Hi guys, this is Dyutis. Welcome to Finance Chanakya. Today we are going to learn about gamma, its properties, how it is related to delta, and how it measures the option sensitivity. So let's get started. Coming to gamma, gamma is represented by represents the change in delta of the option. It is a second derivative of call and stock prices. It is given by delta square C by delta S delta stock price square. So it is two times change. So first change is being given by d by our normal delta, and the second degree change is second differential is given by gamma. So calculation of gamma is given by the formula n dash d1, which is being calculated like we calculate it for the delta, and divide by stock option stock price into sigma into root of time. So we'll take an example and we'll try to understand what it is. So coming to an example, suppose stock of X price is trading at 50, X price 45, 3 months period, risk free rate 5%, standard deviation is 12 annualized. Determine the value of gamma and assume d1 is 1.91, d1 is 0.9767. So you need to understand that it is not nd1 that we are talking about, it is n dash d1. So n dash d1, the problem between means difference between n dash d1 and nd1 is that n dash d1 has a separate formula. So that formula is being used here, and we will be able to find out using that formula in n-d1, and the formula is gives a result like 0.055 for this specification. So if you take n-d1 0.055 divided by s0 is 50 into 0.12, which is nothing but standard deviation, into time t, because 3 months is equal to 3 by 12, 0.125, which is 0.0183. So gamma actually represents change in the option delta. For one change in the price of the stock, the delta will change by 0.0183. So delta measures change in call option price as compared to change in stock price, and gamma measures change in delta as compared to stock price. So that's what gamma and delta means, and we'll move forward with certain specifications. So coming to relationship between gamma, delta, and stock price. So when the gamma is large, delta is changing rapidly. So you'll see the graph of it is like this. Our normal, it is a normal distribution graph, and in which if you see the change, if the gamma is going to be large gamma, then the delta will be changing rapidly, which is because since it denotes a change in delta, gamma denotes a change in delta. If delta gamma is said to be large, delta will be changing rapidly, and when gamma is small, delta changes slowly. So the the delta neutral position can hedge the portfolio in small stock. This is important. So this what this says is, as we have already discussed in our gamma lecture, that gamma means in delta lecture, that delta can be used for only small change in stock price changes. So but this gamma can be used for not only for small changes but for large changes also. So it is not desirable to create a delta neutral position, but it is also desirable to create a gamma neutral position where the underlying stock is hedged using gamma. So analyzing assets like forward contracts have zero gamma, since it has a linear payoff. The things which don't have a linear payoff, the linear payoff means having a direct sync with the underlying asset. When the asset value increases, the payoff also increases. The value of the underlying option or forward also increases. Here it may not be like that for call option and put option, because it works in a different graph. Like if you see, let me explain. If you see the graph of call option, it is something like, if you have bought a call, so at here we'll be losing premium, so at the stock price increases we'll be gaining. So this is not linear. Linear is like when if for all the increasing stock price we'll be gaining only. For this part, in this part we will not be gaining, we will be losing our premium. So that is not linear payoff. Linear payoff is one which if this is a stock price, as stock price increases, the value of this is forward profit. So forward profit also increases in a linear fashion. So that will not happen in the case of options, so that is non-linear. So specific relationship that determines the number of options that must be added to an existing portfolio gamma neutral is minus rp by rt. So not rp, this is gamma p by gamma t. So gamma is actually, this is gamma of portfolio and this is gamma of trade. So this is how we calculate. We'll take an example and we'll try to understand this. This is all about gamma. So that's how we calculate gamma and what is the relationship between gamma and delta, etc. Coming to that relationship between our gamma, theta and delta. So it is given by risk-free rate into price of the option is equal to theta, that is change in time, and that is time decay, plus delta, which is our first differential for change in option price by change in stock, delta into stock price into risk-free rate, plus 0.5 into sigma square, which is standard deviation square, into stock price square into gamma. So this is the relationship between all these things, this simple portion. Hi guys, thanks for watching. If you like my video, like, share and subscribe. If you have any suggestion, comment. Thank you. Thanks for watching.